2 of this. So part 2 of this is like part 2 from yesterday's assignment, Naomi, where we had to like design a study, and basically we're going through the steps that we learned at the very beginning of the class.
Okay, like make interferences and stuff like that.
Yeah. Well, and like, do you remember the David can discern more truth?
Mm-hmm.
That's what we're doing, are those steps for this assignment.
Okay.
Yeah. And then the group meeting quiz will probably be completely different again.
Probably.
So that one number 14 and 15,
Uh-huh.
I emailed Cook about it, and apparently when we have just something that has to do with, or if we're going from like a one-tailed or a two-tailed test to a one-tailed test, apparently all we have to do is divide by 2.
Oh. Okay, that makes sense, I guess. So from going to a 2 pair to 1.
One-tailed to 2. So
One
if
tail
it's
to
saying
2.
like,
Divide.
if you're going from a question and your alternative hypothesis is saying that the average will not equal 0, and you're taking and saying it's going to be greater than 0, that not equal to is a two-tailed test, and then the greater than is one-tailed.
Okay.
Yeah.
Okay. All right, cool.
I'm having issues opening the data, I feel like, that we need for this assignment. And my computer froze. Oh, there we go, cool. Holy cow. There is a ton of data in this.
What do you mean?
Well, like, so we're supposed to open up for part 2 of the assignment, the class survey, right?
Oh, yeah.
And so it has all of the different classes. Female, if people are right-handed or left-handed. Are they on the roll, flip, nose, penny? I'm not entirely sure what all those have to do with anything yet. Their rank, so sophomore, junior, senior, credits, height, fear, skill, state, wage, age, date, random, heart. I'm not entirely sure what some of that data has to do with anything yet.
Open that. Did you just click on that blue and like click on the blue link?
Yes. Okay, all the professors at the BYU math department collected data from BYU students to compare mean wages of BYU Idaho students, male students, to BYU Idaho female students. The students from his classes completed a survey, which he then used to analyze if there is differences in these wages. Okay, so the research question would be,
If there's a difference in the wages between male and female students?
Yeah. And so our null could be that the mean equals 0. Being that they are the same. And our alternative would be that the mean does not equal 0.
Yeah. Okay.
So describe the data collection procedures. I don't know. It would probably just be best to do a simple random sampling.
Yeah.
I'm wondering if they have the same amount of male students as they do female in their study. So we're going gender. That's the one we want to pay attention to. So column 2. So they got 95 female students.
How do you know it's 95?
So in the Excel spreadsheet, they have it starting in row 2, and then the female listing ends in row 96. And since it was shifted down one, and
Yeah,
they go
because
from 1 to 7.
in the SPSS it has female, male, female, male, 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 female, female, female. So it's not like not in columns.
Really?
Yeah.
Weird. Mine's all in row and columns and is fortunately quite nicely divided between male and female students.
Lucky you.
But so do a simple random sampling of 95 male students and 95 female students. So there's 190 students total.
Okay.
Threat has been detected. Threat has been detected.
Then we're supposed to describe the data.
Okay.
The other hard part, though, is that there's a lot of information in here that we don't really need.
Yeah.
We're looking for the difference in the averages between male and female student wages. So we don't necessarily care about like their credits or rank or the role or any of that. So I'm going to do something equals average of
So do we have to like solve something to describe the data?
I don't think so.
We just describe it like
Well, I do know that they want us to try and make it like as simple as possible when we do explain it. So interesting. Apparently there is a difference in the average wages.
so maybe there's a difference?
Yeah.
Yeah.
It's not a huge one. It's like $2 and change. But okay, so we would describe the difference or describe the data. I have no idea how we would describe it because they gave us so much.
I don't know.
We could say that
Oh.
the average wage for male students is, there we go, 11.94 of the average wage for female students is 9.76. Round that to 2 decimal places.
Mm-hmm.
In short prayer. So that's based on this data, male students earn about $2.18 more than female students at BYUI. So what type of hypothesis test is appropriate? Did you read much on hypothesis tests?
Yeah, I read about it. So, well, it's about independent sampling. So it's hold on. Is independent sampling a hypothesis test?
No, independent sampling is the type of samples that are taken, where like the set of data can stand alone, whereas like before when we did dependent samples, that data stood. It wasn't able to stand by itself. If that makes sense.
Well, I'm not sure then. Well, I don't know. Here it says when conducting hypothesis tests using independent samples, the null hypothesis is always mu1 equals mu2. I don't know. Does that mean it's a test? Independent samples?
What?
I don't know. Because the lesson's about independent sampling, so I don't know if that's the...
Yeah, but there's one of them, like section 3 is specifically called hypothesis tests. So, oh gosh. So there's a formula that was in the videos that I wrote down that I think we need to use. And I'm not sure how much I like it.
Is it that one crazy formula?
The T equals x bar 1 minus x bar 2 minus mu 1 minus mu 2 all over the square of the standard deviation 1 over n1 plus standard deviation 2 over n2.
Yeah.
Yeah, that one. I think we're supposed to use that for this one. I'm just not entirely sure how.
Yeah, because, well, let's see. Um, so yeah, because like in that video, it says steps to hypothesis testing when standard deviation is known, when it's not unknown, or when it's unknown, and then the matched pairs, independent samples. But yeah, so you're probably right. But okay, so in the reading, it talks about automatic recode. So I don't know if you have
Right.
to do that.
So one thing that I think is really interesting, I just got the standard deviations for the two groups, like the male and the female group.
Uh-huh.
The female group, although the mean is lower by like the $2 and change,
Uh-huh.
the standard deviation is also fewer by just over $7.
Hmm.
So while guys are making a little bit more money, the amount that they earn also um is significantly different, or like has a wider spread to it.
Yeah.
I think that's interesting. But yeah, so I mean that part would be, so if we were using this formula, I don't know where we would get our X bar and our mu's. Would we just be able to assume 0 for mu again? Like mu1 and mu2? So it would
Yeah.
be like mean 1 minus mean 2. So we're looking for the difference from the men to the women. So we could go men for X bar 1. So we could do it like this. Let me write this out really quick. So we did this 11 point. I'm going to round to the second decimal place. 94 minus 9.76 all over the square root of, both these have a 95 population count, so that's easy. 10.49 over 95 plus 3.17 over 95. So if we calculate that out as what we want to use. Let me do this here. 49 plus 7, 13.66 over 95.
Hmm.
Should we be using the men as X bar 1? Because our question is there a difference? Well, I guess if it's just is there a difference between the amount that men and women make?
Mm. Oh, I don't know. I'm not smart.
Divided by square root.
So, males and wage. So,
So our oh, that is way too high of a number, I feel like. Our test statistic with that would come out to be 5.749,
Wow.
which is way too high. I guess not way too, but it's
Yeah.
pretty high. Hmm.
I'm just trying to work something out here. I don't know what I'm doing.
What?
Trying to, I don't know, do something, but I don't know if it's working.
Well, try it. See what happens.
Let's see.
Oh, here we go.
You got it?
Well, I have. So I found this thing on Excel that is. It was something in the textbook that had like all of the data.
Okay.
And like basically I can give it the values that I need at whatever points in time, and it will calculate anything out for me.
Mm-hmm.
And it's just a matter of getting it to work. Boom. That's weird. Apparently, we have significantly less data from men than we do women.
Really?
Yeah.
Oh, dang it.
Significantly being like 6 people less, I guess. That actually makes sense. So my N there is 7095 is going to be 89. Which is going to change the answer for that question substantially.
Well, it's just hard because like we're supposed to do the difference between gender and wage. Like gender is not really a number, so I don't know.
Right. Well, so here's what I currently have. So let me set a few things up here. So our t-score will be negative 1.953. And then our, dang, what does DF stand for again? Degrees of freedom will be 81. Um, but I'm not entirely sure how like they got the degrees of freedom for that one.
I don't know. I don't know. I wish there was like step by steps or something.
Well, the videos kind of break it down step by step, but I feel like it should be in the reading as well.
Yeah. I wish she's on campus too, so then I can go talk to her.
She lives really close to over here, actually.
Oh. Well.
Like I'm in Emmett. You're from Meridian, right?
Yeah, I am.
Yeah, she lives in Middleton.
Oh wow.
Yeah.
You're really close.
Yeah, I'm
Not-
actually.
And I'm in Rexburg.
I've contemplated going over there. I have like her office hours at CWI. I should go over and see her during those sometime.
Oh, you do? That's lucky.
Mhm. So I want to know.
Oh.
How are they computing our n value?
Engine.
Oh gosh. F7. Test value.
I'm actually going to a tutor tomorrow.
Oh yeah,
That'll help me understand more.
that should help a lot actually.
Yeah, I hope so. Cause like I don't know, like sometimes I understand during the group meetings, but then when I'm doing the homework, I'm like, what the heck?
Right?
I don't even remember. This.
Okay, so I get where they got their degrees of freedom from.
Which you got? What was it again?
What?
What was the degrees of freedom you got?
So the degrees of freedom is 81, and it looks like, so because we have two variables in this one, they took up the number of differences that were in the variables. Okay. So calculate the differences, and anything that didn't give a value, or so like there's 9 more women than there are men.
Mm-hmm.
Or my bad, 6. And then there are a few that didn't give a value. They took that number of however many values they actually got, and then because we had two variables, they subtracted it by 2. So there were 83 given values, and they subtracted blah, 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 2 and got 81,
Okay.
as best as I can tell. And then I think the T-score, let me see. G18 minus that. And then they did the same thing, like where they took x bar minus the null or the 0
Okay.
and divided it by the standard of the mean
Okay.
to get their T-score. Okay, that makes sense then. Okay, I think we can do this. How do you feel about it?
Yeah. Good.
All right, so let's go ahead and hop into the quiz.
Okay.
The quiz yesterday, Joe and I spent probably 40 minutes going through it, hashing it out, and doing it.
Wow.
Yeah, it was.
You guys get most of it right?
We got an 83 on it, I think.
Okay.
So true for those two. Okay, what requirements must be checked when conducting a hypothesis test comparing two means with independent samples, A and B?
Wait, are you starting the test or the quiz?
Yeah.
Okay, hold on. Get in there right now.
Okay, and there's 16 questions.
Okay. Okay, what requirements be checked? Well, it says the sample size has to be large in the reading. Oh, wait, hold on. There it is. A simple random sample was drawn from each of the populations. X bar is normally distributed for each group. So A.
Threat has been detected.
1 second, please. Oh, dang, I think they did use the really complicated formula for us.
You doing the quiz?
Nothing. Okay, what was your question?
I was just doing number 3 on the quiz.
Okay, so number 3.
It's
The-
A and
What?
A and B.
Yeah. It has to be a simple random sample, and the X bar is normally distributed for each group.
Yeah.
Okay. Number 4. The test test statistic, there we go, for a hypothesis test comparing two means with independent samples is the t-score.
Yeah.
And then two samples are independent if knowing which subjects are in group 1 tells you nothing about which subjects are in group 2.
Okay. All right, 6 to 11. I like the Excel sheets that already, like, it's just like the two sample t-test for means Excel thing. It's nice.
Did you find that?
I did.
The two sample t-test
Yeah.
on Excel?
Uh-huh.
Okay, cool, because that's what we're supposed to be using.
Yeah. I'm just saying I like it because it's.
I know, I found it like by accident the first time, and then I realized how much simpler it made my life.
I know. It's awesome.
Okay. Okay, so our degrees of freedom. Bam. Check it out. Check it out. It's going to be 37.996. I feel kind of weird because this part is all computer generated for us, really. It's nothing like, oh, here's how you would solve for the degrees of freedom. It just kind of gives it to us.
Just like put in a number and then there you go.
Yeah, exactly.
Simple deviation was 2. So that would be 206.637.
Yeah, looks like it. If we totally botch this, I'm going to feel like an idiot.
I know, I'll be so sad.
Oh, well, okay, 1 second. H1 is great. It's less than H2. Okay, well, there's one thing that I think we need to change.
You do?
Well, I'm not sure. Do we need to change the type of test? Because the assumption or our alternative hypothesis is that H1 or variable 1 is less than variable 2.
I don't know. I mean, it tells us to use this two sample t-test.
Right, but does it tell us, what does it say as far as I think we need to change it to less than.
Oh, okay. Sure. For the alternative.
Which is only going to affect, like, I don't even think it'll affect the t-square. It only affects the p-value. So I don't think it has affected anything that we've put in yet. Yeah, we were just about to put in the test statistics, which is negative 0.343. And then the p-value is the first thing that I think it really changed. And it's now 0.333.
So wait, did you change it to less than, right?
Yeah, I changed it to less than.
Okay. So then I gotta redo this. So the degrees of freedom is now. Where is it?
The degrees of freedom shouldn't change. The only thing that would change is the p-value.
Oh, yeah. And the standard deviation.
Did it?
Oh, no, just kidding. It didn't. I was looking at the mean. Okay. So the p-value is 0.333.
Mm-hmm.
Okay.
And then our p-value is higher than the level of significance, so we would
So
fail to
failed.
reject the null hypothesis. And then we would, for question 11, it's taking it from a one-tailed test to a two-tailed. So we would multiply our p-value by 2 and get 0.666. And because it's so high, we would still fail to reject the null hypothesis.
Okay. Oh, cool, another one. Same.
Didn't I?
Thank you. The heck? Okay, so then. So it's equal to? So should we change it to equal to?
Well, that's our null hypothesis for this one. We don't know what our
Oh,
alternative is yet.
alternative.
Okay, so for questions 12 to 16, paste the values listed here into the software quantitative inference procedure XLS. On the two-sample t-test, the first data represents the number of times freshman students from Utah cook their own dinner in a month. It looks like they got the first and second sets switched around. A different number, so it's going to be not equal to.
Not equal to, yeah, because it doesn't say less than or greater than.
Yeah. Okay. I'm a little concerned though because they have the freshman students from Colorado as one, but when they ask the question, it says that the first data set represents the students from Utah.
Oh.
So I'm not
That's
sure if
not
that would make
good.
a difference or what exactly. Not equal to is going to be the perfect one.
I don't know. Are you going to keep it that way or are you going to switch it around?
I'm going to switch it just because what they have and what they're saying are two different things right now.
Okay, so the. Okay.
So I'm going to put the Utah, which is the second column, in the
longer.
variable one spot.
Okay. So then, yeah. So that Utah one's shorter than Colorado, right?
Yeah.
All right, I'll switch it to. If we get it wrong, should we like email her and tell her?
Yeah, we can do that. When I've had issues with stuff in the past, she's been really good about letting me change it if I've needed to. Okay. So.
And still not equal to?
Yeah, it'll be the same test. The test statistic. That is just a weird thing to say because it's like test statistic. You have like TESTST.
Negative
Go
0.845.
Yep.
Point 410. Oh, whoops. 411.
And then our level of significance was it 0.5 or it was 0.05.
Point
So it's
0.
kind of failed to reject. And then the confidence interval should be given.
Yeah, negative 5.147. Negative 5.147 to 2.214.
Okay. And we answered all the questions. And to
Yeah,
be perfectly honest, this is the best I've felt about one of these quizzes in a long time.
yeah, me too.
So
Thank
I'm gonna
you.
submit. Okay. And bam, 83.
Dang it.
Interesting. We missed that test statistic one.
The one we switched?
No, for number 8. It was the first set of data.
Interesting.
Yeah.
Oh, yeah.
That is weird. I wonder if we didn't round it right.
Maybe.
I'm gonna.
Let's see. The side represents somewhere in the gentle bills. Wonder if it's like the same thing, like we have to switch it around.
No, because in the wording for the question, it has Idaho Falls listed first, so we did that part right.
Yeah. Weird.
Oh, we read it 343. It was 434. Huh, dyslexic moment. Oh, and we got 13 and 6. So we did get that test. We got 13 and 16 both wrong.
13 and 16?
Yeah. So I
Yeah,
wonder if
but then
we switched it
why did
around.
we get... Yeah.
I don't know anymore.
At
Oh well, we're done.
least we didn't fail it.
Right?
Well,
Okay. Well, cool. Thanks, Naomi.
yeah, thank you. I guess the homework seemed a lot harder to understand, but...
Yeah, it usually is. I feel like the homework is generally significantly harder than like our little group stuff that we do.
The preparation was harder to do. That's what I meant.
That too.
All right. Well, thank you for meeting with me earlier.
No problem. Do you have any questions from like yesterday's stuff that you want to ask?
I don't know. If I do, I'll probably just ask the tutor, I guess. I don't know.
That
I don't
works.
really have questions right now.
Okay.
But
Then
thank you.
I think I'll just email this to Joe and Tyler.
Okay.
They can go
Sounds
from there.
good.
Cool.
Okay.
All right.
Thanks, Dylan.